What's up, y'all? It's another beautiful morning. Today I'm working on a game I'm making in the Godot game engine. Uh, it is a 3D um, JRPG, maybe? Anyways, this is what I have so far. Basically, I have walking, I have talking. You can talk to this box over here, and you get like a little bit of dialogue. I think the audio is coming through. It's just like a little. Um, So you can talk to people, you can walk around. I'm doing movement relative to the camera. So depending on where the camera is, you determine, like, if I press W, it goes forwards to the camera. If I press D, it goes to the right. So that's relative camera movement. That took me a while to figure out. I also have traveling to scenes. So these are doors. And if you walk into it, you walk through the door. It's pretty neat. Just still feel a little weird, but we're prototyping right now. And then if you walk through, there are now 2 players, but that's because I'm just loading the scene and there's another player in it. So there's 2 players, but not an issue. Anyway, so this is the game so far. Today is going to be an adventure into stickers. I have walking, I have talking, I have traveling to scenes, and I figured the next most important thing was stickers. So I'm going to see if I can come up with a system where you have all these cute little stickers, and you can just stick them on, like, boxes or yourself or anything. And then I want it to remember, so that when you see that object again, it's like, oh, here's all the stickers you put on me. And I'm also going to need some way to place them, so we're just going to wing it. We're just going to send it and try playing with it. So first I probably need a sticker. I'll use Krita for that. I'm going with a pretty small resolution game, so we'll try 32 by 32. Whoa, flashbang warning. Alright. That's nice. We'll start with a heart. Boom. That looks terrible. Okay, maybe we can find stickers online for now. I'll find a sticker online. A quick heart sticker. Sure, that looks good. There's so many. There's like more than I should have the option to choose. Copy image. I'm actually going to open up Paint. Paint.net. It's my one true tool. 32 by 32. Just because I know how to use it. Very good. So we have a heart. We get rid of all the... Alright, so we now have our heart sticker saved somewhere, and that's very cool. So now we have the image. We're going to make a folder in our assets. This is how I'm organizing my project. Folder, stickers. If I just find and drag in that little heart sticker, nice, we have it in the game. I'm definitely replacing that. I don't like this sticker, but we're moving fast. So now we gotta figure out how to place it on things. And I was thinking a decal. So let's make a generic decal. Got this window up here. It's gonna be a decal. And I think we just slap this in here somewhere. Texture, albedo. Yeah. What is ORM? Oh, that's cool. Cool. Give it a name of sticker. Save it. We'll do asset stickers. And this will be a prefab sticker, so PR. I'm using PR so I know what is actually a scene that I've made sure works and is good. In Godot, you bring in your raw models, and then you don't want to just use the raw models. You want to make them, you want to take them, say stop, I'm going to put you in your own scene. That scene is called a prefab. And then if you make changes to that prefab, it'll affect every single one of them, and it just makes it way cleaner. Don't use the raw models or textures or anything. So this is PR sticker. And we'll see. I want to make it so that you can configure it, you know, put whatever image you want on there and put the sticker on. So if I have our little cute little player here, and I give him a PR sticker. Wow, he's on fire. Okay. Gonna have to fix that. Let's go to our sticker scene. Maybe we'll make it 0.1. Something like that. Boy, that doesn't look good. That doesn't look good at all. What's going on here? Well, let's look at this. So we import this heart sticker. We're compressing it. Yeah, I'm not sure. Very strange. Let's put it on something else. For my dialogue system, I'm using Dialogic. I forgot to mention that. New box mesh. Yeah. That's just not right. That's not right, fam. How is this supposed to work? I guess I really don't know how decals work. I've used them before. Oh, that's so weird. Um, okay, so why is this happening? Let's get rid of this. Oh, yo, that's kind of sick. It's got like racing stripes. But that's not what we want. So weird. Give them 0 0.2, 0 0.2, 0 0.2. It's starting to come through. Let's look at the documents. Oh, by default, decals are projected down for positive Y to negative Y. This is why we read the docs, man. Hell yeah, let's go. That's how it goes, man. Let's do it. Get all this out of here. There we go. So we have our heart. It's cute. It's chilling. Oh, that's so nice. That's all I need in life, man, is stickers. That's beautiful. Look, give him a little heart. I guess that ball's like so you know there's something there. That's so cute. Now we're cooking. Alright, so we have a sticker. We just gotta make sure that it's projected in the right direction. And or rotate it when we apply it. So that's cool. What's next? If we look at, I think Krita died. I had a drawing there. I think Krita died, yeah. Anyways, we need sticker memory. Sure. Oh. We need the memory, and we need to place them. So, how are we going to do that? Well, we can do this. Let's do this. Let's do a memory. Now we should probably do the placing first. So, alright, yeah, let's do this. So I want it so that, just give me creative back. I want it so that when you select your item, oh, so we have sticker. It's gonna be a long video, but this is the content I'm making. Sticker. We're just chilling. We're chilling. We're here. We're doing projects that are fun. We're enjoying them. And hopefully you learn something in these slow moments. So for the memory, I'm thinking it's just like a node that's like a sticker mem. And then he's going to keep track. He's going to have a little script on him. A little script. That's not a script. He's going to have a little script that's going to look for other decals that are of class sticker. He's going to mark their position, rotation, and then when you need it next, it'll just be like, here's your heart sticker, you put it here and you had it rotated like this. Here's your star sticker, you had it over here, rotate like that. And then that way when you play stuff, you can save it. If you leave the scene and come back, it'll remember. For the placer, I was thinking, and this one's probably going to be the hardest part, we make a UI, which is something new for me. I make a UI menu. In that menu, it's isolated. Like, you'll be playing the game, this menu will pop up, you'll have your box, and you can rotate it around, and there will be a menu on the side with all your stickers on them. And you can select the stickers and you click and drag and you place the stickers on there. And you can rotate this. So we'll see what's going on. There we go. Another thing is we gotta make sure the decals only stay on the things they're touching, but that's an issue that we will resolve later. So let's make a menu, I guess. I'm gonna do some research real quick. Godot, 3D menu in 3D scene. Cause that's what we got going on. Creating a 3D menu. It's a problem solving thing, they say. Yeah, I agree. I fully agree. Let's just wing it. Let's see what we can do. So I'm going to make a 3D scene. This is going to be the sticker placer UI scene. Sure. Let's save it in haven't made a UI folder. I'll save it as stickers. Sticker placer UI scene. How about that? Keep all the stickers together. In this scene, we will have. Basically, I just want to be able to rotate it. Rotate something. So mesh instance. And then I'll put a script on it. Put a script on it. Okay. And now I need to go back to Google, my best friend. Godot. How to rotate object with mouse. Mouse input to rotate an object is an archive. 2022. The thing with Godot, when you're Googling, it depends on, because like Godot has changed versions so frequently. It's like half of the stuff is for Godot 3, half of it's for Godot 4. But the concepts are kind of the same. Oh, this is good. Yes, it's good. All right. Let's do this. So is dragging. It's going to be a Boolean variable starting with false. In physics process, if input is mouse, is button, is action just pressed, which is left click, and I say is dragging is true. This way, when you click the mouse, you say I'm now dragging. When you release it, just released, we say it's false. I'm no longer dragging. Now, if it's dragging, then we need to get the differences in the mouse position. They're doing this in input. Which also works for us. And we'll do like this. I wasn't going to copy this guy, but then I had the thought that we need to be able to access this, and I was going to do it in physics process. But if you do it like so, if you do his is this, is dragging, an event is mouse motion, then we can do this and rotate our mesh. If we rename this to mesh, and we actually give it a mesh, we should see some rotation. Where's the box? There we go. Okay. I'm going to run this specific scene, which is sticker placer UIC. We don't have a camera. Camera. And cool trick here, if you do camera align transform with view, it'll match the camera to look at what your thing is looking at. That's our game. There we go. Sticker. Cool. Thank you, Google. And Antares from 2021. It sort of seems to work. Let's give this scene its own environment. How does his code not work? This is literally his code. Sticker. He's like, my code's not working. I literally copied and pasted it, dude. It's working. So it kind of works. There's like issues. Like I'm dragging up. He's technically working, but not the way that is intuitive to your brain, you know? It's cool though. Like when I drag down, it goes the other way. When I drag down, it goes the right way. So this is correct. This is not correct. This is not correct either because it's on that angle. Now that's correct. So I think I want it relative to the rotate object. Whoa, what did I press? Here, let's do this right. Is dragging bool var, actually on ready var. This will be our our node for controlling. So mouse control root, because this will be the thing that we control, and then we just slap our mesh on top of it. So this is the root. It's going to be a node 3D. And give me a node 3D. Mouse control root. If I put the mesh on here, then I can now just drag this guy over here. Now we have this, and instead of rotating the mesh, we rotate this root. So we do root rotate. Let's do rotate. I'm gonna do we want to global rotate? Sure, let's do global rotate. See how that looks. Global rotate on up, and then we also want that. Let's see how it looks. We probably want to do some relative calculation. Where's this scene? If I set as the main scene, then I can just quickly hit play. Don't have to search for it. Okay, that feels way better. Still a little off. Left and right is good, no matter which way you spin it. Up and down though, like that's right, that's wrong. But you know, this is mise en page or whatever. This is the small stuff. I need to put stickers. So now I will Google Godot mouse position in 3D, which actually I'm not even gonna hit enter because I've done this in this project already. Test grid scene. I made this scene, which I can actually run, and it will definitely crash. Test grid scene. When I started this project, I did not know what I wanted to make, so I was going to make this Dungeons and Dragons type thing. But basically, you can see that I've clicked, and it crashes if you click twice. But that crash brings us to my code. Mouse select area. Project raycast. So when I left click, get the mouse position, get the camera. Yeah, let's just yoink this. There we go. And let's make it right click. Now, ideally, I'd want this to be set up for controllers, because I think this game is really going to be a controller type game. So I'm adding to the input action map right now, actually. Probably should show you. I'm hooking up the right mouse button to the right click control. You just type in here. And when this clicks, now we will raycast from the screen. This project raycast is missing. I don't know why I did it like that, but we'll do it. You're gonna see a lot of red, I'm sorry. Where is my code, dude? Mouse 3D Manager. Oh. Oh, this is like a thing. This was meant to be like a mouse 3D Manager type thing. that you just throw in there and then you can touch things with the mouse. I like that, but it's not happening right now. I'll make this a reusable component later. So on start, we create our raycast. We create a new raycast, add it to the scene, deferred, say collide with bodies. Then when I right click, we get the viewport mouse position, which is a mouse screen position. We get the camera. We set the origin of the raycast. Is this gonna work? No, that's not gonna work. That's so small. We set the origin of the raycast to the camera. Target position is the mouse screen position. Project, you get like the angle. It's like you have your camera. Wow, here's your camera. You have this. You set your origin to the camera, which is, on the screen. You get the mouse position, which on your camera, if this is your camera, your mouse position is like up here. Your mouse position is going to be like there, so you go there, and then we get the normal of the camera, go that way, all the way until you hit your object. So you just project that way until you hit it. That's essentially what's going on here. Alright. If we hit, then I say, oh, my raycast hit. Then we move the mouse select area. But I'm not doing that right now, actually. What I'm going to do is delete this stuff because this is grid map specific. This is the collision point that we've hit on the mesh. So I will instantiate a new sticker. Give me the sticker scene. Instantiate the sticker scene. Let's get the object we hit, which is this guy. Var hit object. It's going to be a node 3D, it has to be, because it's in 3D space. And we're saying it is equal to that. We're going to add child. Hello, add child. Why is this having issues? Add child sticker. I think we want to call deferred on that. So we wait until call deferred is waiting until Godot no longer has like stuff to do, particularly in this script, which is like very helpful for like when you're adding new stuff. Like if you're adding a new child to the scene, like first you have to instantiate it. That takes a little bit of time. So when you call defer, you're saying like, okay, once you've instantiated, which I know will take some time, once that's all good, then you can add it as a child, later, whenever you want. Instead, if you didn't call deferred, it would be like, okay, create the child and then immediately slap it in there. And they'd be like, no, like it takes some time to spawn all this stuff and set it up, a couple milliseconds or whatever, but like it still takes time. So this way you say like, all right, take your time. When you're done, just put it as a child. And it's like super chill. So we add it as a child to the hit object. And next we want to put it, we want to set the sticker global position sticker scene. I know you're gonna be a node 3D. We're gonna access the base class. A decal inherits from node 3D. So I know you're a node 3D. I'm gonna set your global position to this raycast position point, collision point. And then we want to make sure that the bottom of the sticker is facing the object we added it to. In order to do that, we'll do sticker we're going to set the global rotation to the, here I gotta Google this, Godot road. So I know how, let me draw it out. So we have our box. We're gonna look at this from a side view. We have our sticker. This is our sticker. We add it, but what we need to do is we need to rotate it so that, if this is the origin to there, we gotta, you know, find the direction from the sticker to the object, find the rotation that'll make the bottom of the sticker align with that direction. So you actually want the normal of the face that it's on. Yeah, let's see. Okay. So first step is Godot rotate to, not rotate to match face. We'll see if anyone said that. Rotate to a direction, because that's kind of what we're doing. Rotate to a direction. Okay, so we'll try this. We're going to say sticker, look at the position that you were placed on. So that should rotate it in some way. We'll see how it rotates in action. And then we'll put it to that position. Boom. I need some milk. Need some milk. Let's have it do this. Print spawning sticker. We'll do visible collision shapes so we can see if this works or not. Spawning sticker. Actually, all that tells us is that we right-clicked. Doesn't look like it's colliding, and you know why? Because we don't have freaking collision on here. That's why, man. That's why. We don't have any collision on this thing. Let's look at this. Here we go. We don't have any collision. And I'm gonna make it a static body. Put these as a child. And now we are good, I think. Now we can collide with it. So rotating, collide. So we've hit the raycast. I'm still... Am I seeing a sticker? I think I see a sticker on there, man. Let's get rid of these debug visible collision shapes. I think I see a sticker. I see a sticker. Yo! Okay, the top one looks really good. That one just did not work. I think it might be upside down. Okay. The first sticker looked really good. I'm gonna bring the camera in a little closer. This way you can like actually see. Oh, and then we'll have to rotate the stickers. Man, this is a task. Got some errors. Node is not inside tree. Oh. So, we need to call deferred on these. Let's do this. Func align to target. Sure. And we will pass in our sticker, which is going to be node 3D, and our hit object. Well, we don't need it actually. Hit object position, which is a vector 3D, vector 3. And then we say this here. Boom. Don't need to call deferred anymore, because what we will do is we add the child, and then we say after you've added the child, align to target dot call deferred, and that will call that function once it's all good, I think. So we shouldn't get those errors. However, we probably still have some issues, but let's see. Let's do a little testing. So boom, add a sticker, did nothing. You're doing nothing. It's doing nothing. Oh man, we're so close. Does this even do anything? What's going on? Hit object is never used. Oh. Oh. So goofy. Yeah, and you're not even calling it with any objects. Oh man, amateur hour. Shoot, what was that? Just project raycast. Get collision point. There we go. Amateur hour, dude. It is 5:40 in the morning. There's no excuses. Here we go. Nice. Alright. Fellas. Ouch. Fellas, we have sticker placing on a box. And that one looks like a heart. It's kind of weird. So, depending on where you place it, like up here, it's working fine. Fine and dandy, no problem. Down here, very weird. We gotta figure out that. God, Wow. The sticker works. The sticker works. Oh, that's great. That's amazing. All right. We have a sticker placing. We'll need a... Is action pressed? Is action just pressed? There we go. That should help a little bit. Now we need to align the target. So, what we're gonna do is we know our sticker position, we know the position of the hit position. So I want to rotate to align. Godot. Rotate to align. Yeah. Rotate a 3D object to align with terrain. That should help us. So we have our transform basis.y. We want to align it with our hit normal. Our hit object normal, which is easy to get from our raycast. Get collision normal. If we control click on this, get collision normal, it returns the normal of the intersecting object's shape at that collision point. Very cool. So, now that we have that normal, basically calculate the angle between the object's up vector and the hit normal, and then rotate U object with that angle around the axis that is perpendicular to both vectors. Very cool. That's exactly what I was thinking. We need to find get the angle between our up vector and the hit normal. And then we will rotate the sticker around the axis that is perpendicular to our thing, perpendicular to our both vectors. So there can only be one axis, I think, to rotate around. So you need to determine an up vector. We're coming back here again just to try to figure this out. So you have this, right? That's fine. I have this. I want to match. I want this guy to match your guy, the top. Man thinks for a long time. ASMR. Gosh. So, we're going to cheat a little bit. That's really bright. We're going to cheat a little bit. In my mob class, I've figured this out in the past. I have a function called rotate towards motion. So I get my current direction, which is the direction the player is facing. I'm the player, I'm facing this way. We get the target direction, which is the direction we're moving, which is, you know, if I was going that way, I would want my forward to face the direction that I'm walking. You probably saw this earlier in my scene. Then I get the axis to rotate on. I know I want to rotate on the up axis because that makes sense. You rotate on the y axis, you're spinning. That's cool. That's how we walk. In this case, I don't know if that's the axis I want to rotate around. Let's send it, see how it works. How about that? So, we calculate the angle, we get the sine angle from the two vectors. And then I just rotate. But I rotate slowly, so this way we can just rotate like our rotation plus that, but we know which axis we're rotating around. Oh, so I think we just have to pick one. All right, this is just thinking live. Copy this, go to this, line to target. I'm gonna put my code here and then cut everything out, pretty much. Get the angle between our up vector and the hit normal. I think I have enough information here to make it work. Current direction. So we don't want the current direction. We want the bottom. We want the decal direction, which is going to be the sticker dot transform dot basis dot y. Since the decal is drawn from y to y, like on the y axis. So now we know which direction that's going. This is either right or it should be negative. Our target direction is our normal. We have that. Target direction is hit object normal. Get where we want to point. That still holds true. Get the axis to rotate on. I'm going to leave it as vector up. If axis equals vector 3, 0, then you can't do this stuff. So I left this in as a check, and I'm glad I did because now I think we will use it. Since we know that this is vector 3 up, our axis is never going to be vector 3, 0 because we know it's going to be vector 3 up. We just set it there. But I think we're going to have to set this as something other than vector 3 up, which means that this could happen. So I'm glad we left it. Make sure it's not 0. That's important. Down here, calculate the overall angle we need to rotate. So if I just take decal direction, sine angle to target direction over that axis, interpolate the y rotation. How about set the y rotation? And I'm going to run this and see if it works. Plus equals angle. Boom. Add to our angle. Yes. Okay. Don't do that. The stick it. And then I'll set position. Cool. All right. That should. I don't think this is gonna work, but I want to see what it does. Boom. Yeah. See, up here is fine. Perfectly fine. Very chill. If I rotate this to be the top, still doesn't like that. How's the bottom look? Bottom is good. So I think what's happening is we're aligning the decal with this cube's local space. So now we just have to figure out how to not do that. Or do that for everything. These are some good looking stickers, man, though. And the rotation seems to be different. How is this rotation working? Weird. I'm just writing random code and trying to see behaviors that happen from it. And honestly, that's how I learned most of my code. Just seeing what works. So, in one of my other projects, I've done this. The answer might be right here, actually. We're nearing an hour. I would just be happy to place stickers on the right direction, and maybe we can call it at that. Let's do this. Let's do it, brothers. Let's go. And once we solve this problem, we'll be able to solve so many more problems too. Decal direction. Alright, to start, let's invert this and see what happens. See how that works. Same behavior. Except this time it's very interesting. How about the angle of it? Okay, no significant difference. We have the normal. Get the axis to rotate on. I need to do this. So we have, I don't have two right hands. And right hands are in here. We have up, forwards, left, and then this, we want the sticker, which goes like that, to align with whatever it's almost 6 a.m. Oh gosh. I want to make the y-axis, let's type this up, get the y-axis of the sticker to point in the, well, it's like, it's not the y-axis, it's like the transform dot basis dot y axis. Get the transform dot basis dot y of the sticker to point in the direction of the hit object normal. Godot, get vector to point in direction in another direction. Maybe draw it. It will be easier to help. Transform.basis x form. Let's pull up the docs here. What does this do? X form. Transforms a given vector 3 by this transform. Huh. Let's try it. Let's see what happens. So if I just I'm gonna comment this all out and say sticker dot transform dot basis dot y dot x form x, that's on the transform x form what? It's translated. Oh, that's sideways. This might be it. This might be it. I want, okay, var, okay, sticker.transform equals sticker.transform, looking at target vector 3, hit object normal, that's good, and that, and then I think what we would do is, what does this do again? Returns a copy of the transform rotated so that the forward axis points towards the normal. So I'm gonna be looking like this, and then my y is gonna be drawn like this, which is not the way we want it to go. So then I need to rotate again, like this. I gotta rotate like this. Oh, we're so close. We're gonna go over an hour a little bit. We rotate up 90, which means rotating on the rotate object local on the vector 3 dot right axis, and I want to do it in deg to rad because that's how that works, and I want to do 90. No semicolons. Let's go. I believe in magic. Okay. Okay, it seems to work except for whatever happened there. What? No way. What is going on there? What is that? Why is this happening? That's so weird. What are these errors? Maybe these have something to do. Line to target. Target and up vector can't be parallel. Where does this happen? Oh. Let me run this again. So I'm giving it no rotation. Yeah, look at that. So the y-axis, the y-axis, they can't be perpendicular. Returns a copy of the transform rotates so that the forward axis points towards the target position. The up axis points as close to the up vector as possible while staying perpendicular to the forward axis. The target and up vectors cannot be zero, cannot be parallel to each other, and are defined in global parent space. So all we have to do is say if hit object normal equals vector 3 up, is not equal to vector 3 up, then do this. Yeah. And also do that. Oh, boys, I am. What the heck is going on there now? Huh. I think we were really close. I feel like we're really close. Ah, screw it. I'll keep working on it. You clicked on this video, man, not me. You know what you're getting into. Wow, that's so weird. Why is that happening? So when this is facing upwards, we have issues. The side is cool. That's so bizarre. Alright, this will make sense eventually. Oh. How about forward? So if our normal is upwards, then we have to find a new axis to rotate around. So we'll say like do the forward axis or something. Actually, I'll do right. I don't know. I don't know what I'm doing. I'll say print rotating to align with normal on right axis. And then up here I will say rotating in align with normal on up axis. And we'll see what the difference is. Debugging is super helpful. Let's go. Alright. Boom. So we're doing the right axis. It's not right. I'll tell you that. Doing it on the up axis. Yeah. That's some good stuff. Okay, it looks weird on the edge, but that's expected, actually. So look at that. On the right axis. Why? Why? Let's get rid of this for a second and see what happens. Yeah, that's terrible. Okay. Aligns our forward face to the normal. So, okay, You have a box. I'm just gonna draw this over and over again until it makes sense. And I have a face. I'm a dude with my face on there. There's my little ear, my shoulders. I'm facing the box, the normal. I'm facing this normal here. My face is on your thing. So then I say, okay, let's rotate so that I can paint. Boom, boom, boom. So we rotate, and I'm chilling. I'm happy. I'm chilling. My face is up here. And now everything is painting that way. So cool. So then what's the issue? Let me get back to where I liked it. Oh, it is where I like it. Okay. Whoa, wait a minute. On the right axis, why is that not working? I thought that was working. Was that working? Oh man, this is atrocious. What the heck? Let me try it one more time. Okay. So, we know up is not working. That's weird. The side's working. The side's working. Let's see about this side. This side's not working. But it's also relative to the camera, right? Or can I make this a side? Let's see. Yeah, this rotation system kind of sucks. It's so hard to do. Okay. That doesn't work. So it has nothing to do with the camera, right? Yeah, that's fine. So it's specific faces that we're having issues with. But it does have to do with the camera, or rather, not the camera. The camera's unrelated. But it has to do with the way that the box is rotated. Because you can see these are drifting a little bit. So to define our problem, dude, what is going on? It's so weird. I wonder if AI voices can whisper. That would be weird. That'd be a weird world, man. Just have like a little AI whispering you. Hey, man. It's going to rain today. Alright, so something's not right. I don't know. Why am I making these videos? I guess just to show how simple people like me and you and I can break down large problems like making a video game into manageable steps, like working on a sticker system, how we can work through all the problems on these steps, these individual parts, by breaking them down into smaller parts, smaller problems. Like we needed to rotate, we figured out how to rotate. We needed to figure out how the mouse works. I kind of figured that out earlier, but figure that out. We had to figure out how to get inputs. We got that done. We had to figure out how to spawn stickers. We got that done. Now the only issue is we have to get them to rotate in the right direction. And this seems to be very challenging to me. But in reality, I think it's just a matter of perspective. This is our sticker transform basis. Let's look at each line. Our target direction is the normal. That's very cool. If the normal's not facing up, then we can rotate looking at the up direction. Use model front shouldn't matter. Should not matter. By default, yes, this is how I understand it, so that's good. We're using the minus z axis, which is universally forwards. The camera forwards. It's treated as forwards. This is how it should be. This is the way. So that's cool. I'm even going to explicitly say, so I know, we're using vector 3 up. So I make it so that my forwards is facing the normal. Sticker, object rotate local. Yeah, so now I'm facing that way. I want to rotate it. Let's try a -90, because that should have probably the same effect. I don't think it matters if you're going from bottom to up or up to bottom. All right, well, let's isolate our variables. Cap fam, cap on God. Here we go. So, what? I'm so confused. Yes, I think we're onto something. So you'll notice when we're rotating in 90, which I think is this way. Actually, we can find out. If we look at, say, this, and we go here, our transform, if we go, well, it's not that, it's on this axis. If we go 90, we're actually rotating backwards, so we want to do -90, since our face is facing downwards. Yeah. So when we rotate 90, we are rotating further backwards, so our top of our head, essentially. If we are the sticker, the top of our head is facing the normal. And that works on, which is what we're currently running, that works on not the top face, does work on the side face, does work on the side face, and it works on the does not work on that. Oh, so confusing, man. Maybe it'll help to see someone struggle on your coding journey. If you think, oh, I'm struggling a lot, coding's hard. Yeah, it kind of is. But we'll get through it. All right, let's do this line by line. So this is our head, top of our head. This vector is, if I'm the sticker, it's pointing straight up. Our normal. Say if my desk was the cube, it's facing up. If it's not equal to up, we do this. In my case, it is up. It's directly up. So in this case, we do right. So now we're going to do it so that my head is looking at that. So is this even, we're not even using this. My head is looking at the desk because I rotate around the right axis right here. Still, I should do this. And I would even venture to say that. So we draw from top to bottom, no problem. Top works, side works, that works. All those are looking good. And, you know, I do think, like, look at that. It has to do with this rotation. It has to do with the rotation of the object. Looking at the normal, the normal shouldn't matter. That's like in the right direction. I don't think it's the position either. So why is it having... This might just confuse me. Yeah. So hard to see. You know what? I just had a brilliant idea, and it's a shame that it took this long to come up with that idea. But you know what? Every mistake we make. What is this? What is this mesh instance? That's right. Every mistake we make is just knowledge gained. Let's do 0.05. 0.1. It's still not even enough. 0.1. Yeah, that's fine. Okay, so this is facing forwards, and I'm even going to make it blue. Blue. Very cool. Duplicate it. Have it rotate that way. Then in here, I think I can do make unique. And now if I change this color, it should not. It does impact both of them. Why did I do that? Save. Sorry, I said make new unique. Try it again. Why do you do this to me? No. Dude, make unique recursive? Or is it the fact that this whole thing needs to be unique? Make unique recursive. Yes, do the mesh and the material. Now I can make this green, but I actually want it to be red. So now we have red. Duplicate this, do this. So what I'm doing now is I am making a little gizmo that will show me everything I need to know. And the answer will become so obvious once we have this. Ta-da! This is our sticker now. Actually, let me double check. Sticker? Okay. I'm going to do it in the direction of arrows. So this is in the positive z-axis direction. This is in the positive x-axis direction. And this is in the positive y-axis direction. So now we know what that means. Man, time's flying. Here we go. Okay. So what this means to me is that our x direction, our positive x direction, is going into the cube. If I do this here and here and here, that's very cool, because now we know for a fact that our normal is aligning the way it's aligning flush and flat, which is good. So now we know that on the top face, when the thing has no rotation, it does that. And then when it doesn't, we're starting to see some behavior that does not make sense to me at this moment. This also looks kind of cool. It's like a bunch of lollipops sticking out of a cube. Man, what on earth is going on? What this means to me is that something's wrong with our rotation formula. Which I feel like we knew before, but before it was a little confusing because I'm not very familiar with decals. I don't know a lot. But now I do know that your rotation is not the way it should be. Now look at this. This is almost a perfect... See, even this is not perfect. This is almost a perfect placement. The green, I don't know how well you can see it. The green is facing directly out, and we have a nice decal on there. The green is facing directly in, which seems to not be an issue, but regardless, our issue is that the way I'm doing the normals is not working, and we need to revisit that. Okay, I think I'm gonna call it here. We got decals placing. Essentially, I can place them. I'm gonna zoom the camera in even more. To recap, we have placing. We can, you know, move this cube. We can place it. We can right click to place, but our rotations are not aligning the way that I thought they were in the code. But thankfully we have this little gizmo that's super helpful. And I can see that if we look at this one here, this green axis should be facing directly into that rectangle, but it's not. So we need to figure out how to make that happen. Tune in next time, probably tomorrow morning. And we will figure this out. See, that's a nice one. That's a nice one right there. That's what we're looking for. Anyways, stay strong.